Good morning. Hello, kids. This is Mrs.Z. Today we're going to talk about square and we're going to construct square and talk about square's properties. What is really square? Square is a shape, it's a polygon, it is quadrilateral, which means it has four sides, and it's parallelogram, it has parallel sides, and it is rectangle also, and square is a rhombus. All that is a square. It's a very special shape or figure. So if I make parallel line to the edge of my with my triangular ruler, I can draw the line, for example, this big, and I will decide how long the sides I would like to have. So all my sides have to be same. So I choose them to be 7 centimeters. So let's see. So this is 7 centimeters. Okay, and those are already, this is one segment that is going to build my square. And I need three more like that. So 7 centimeters, and I need right angles. So right angle is 90 degrees angle, and I can help create right angle in any shape by using my triangular rulers. I can make a parallel or this green triangle, and I can do the opposite yellow triangle perpendicular to it. So, and then I can create another line that is perpendicular to the first I have. So right now I have a right angle, and I can show you what right angle means if I use my compass and I create a circle around that. You can see that my, see, my right angle lives in a circle, and it actually cuts circle in four equivalent parts, which is, so this part is 1/4 of my angle. If I extend my lines down, this is line segment. In this line segment, I will make four right angles because the whole circle is 360 degrees, and one part of it is my right angle. So far, so good. So let's talk about the other side. So now I need set 7 centimeters other side. So this one is about 5. So I just needed to extend my line to be 7. And it's right here. Okay. After that, I can use perpendicular line toward that line segment, and I can draw my line, or I can do the parallel lines by using my two small triangles. This is my favorite one. I make the very sturdy this yellow triangle, and then the green triangle is on my line segment below, and I just scroll up my with one finger that line, and I can make a parallel line, and that will be my next line segment. So you can see that. And then need just to make 7 centimeters. So I'm gonna extend my line till here. I will check, am I right? And it's also 7 centimeters there. So I can do parallel lines right there, and it will through the, oh, that is 7 centimeters. Here you go. Okay. So we can usually we label, for example, if I label A, B, C, and D square, each side would be, we use only the lowercase letter. So, for example, usually they label as a S as a side of this, and you can just put here 7 centimeters. I don't need to label all this because I know that square, but if I would like that, I can, because everything is, this is S, this is S, and this is S side. So everything is side, and every side is a 7 centimeters. So, and also every angle is 90 degrees. So square has 4 right angles. And if you see that little square that I create, that tells you that this is a right angle. This little square in the corner is how we label how we label a 90 degrees angle. So if we would like to say that angle A is congruent to angle B, and it's congruent to angle C. It's also, sorry, forget that angle C, and angle C is congruent to angle D, and all are equal to 90 degrees. Each of them is 90 degrees, or called right angle. Right angle. We also can label the line segment. So line segment is like AB, capital letters with the line on the top. AB line segment is congruent to, this is a symbol for congruency, is congruent to BC line segment. And BC line segment is congruent to CD line segment. And the CD line segment is congruent to DA line segment. And they're all equal to, forget the line, to 7 centimeters. We also can measure in inches, so if kids wants to know what that is about. So if we look, that is about 2 whole inches, and then we have 1, 2, 3, 4, 5, 6 parts, 6 out of 8 equal parts that makes a next inch. So we can say that S is also equals to 2 whole inches and 6/8 of next inch. So 2 whole inches and 6 out of 8 parts of next inch. Um, we can have a definition for a square, and square is parallelogram. So let's write it down. Is a parallelogram with 4 right angles. And all sides congruent. Okay, so we can say that has sides, has a 4 congruent sides. Okay, angles has a 4 right angles. And now we can explore diagonals. So if we look at the diagonals, we can cut from B. If we cut shape from B to D, that's a first D. It could be D1, and then or A to C, and that could be a D2. Diagonal 1 and diagonal 2 are congruent. And we can also measure the diagonals, so we can prove that they're both, because all the sides are the same, all the angles are the same, the diagonals are the same, and that is 10 centimeters. So this one is 10 centimeters and other one is 10 centimeters. So we can say D1 is congruent to D2, and they're both equals to 10 centimeters. Okay, 10 centimeters. So we have a two congruent diagonals. Now we can explore symmetry, and symmetry is if we cut the shape into equivalent parts, that the both parts will be the same. So we already have two diagonals are also our symmetry lines. So if we cut the shape in between a D and C, we can see that this part, this triangle is same as this one. And then if we cut the shape in this ABD triangle is the same as BCD triangle. So we can see that these parts are the same. We also can find the half of the point in between 7 is that 3.5. And here's 7 and 3.5. And then we can draw the line through, and that is also one of the line symmetry there. We can do the opposite. So 7, 3.5 is a half. 7, 3.5 is here. So if we connect these 2 points, we will see that this is another. So we can extend the line. So this would be a L1. This would be L2, and then also diagonal L3 and L4. Okay, so L4. So we have 4 a line of symmetry. Okay. To explore a rotational symmetry, we can use some of the papers that is see-through, or how they call butcher paper, or hamburger patty, or so we can use our marker and trace the sides of the square. And if I take this, I can trace the sides. Okay, make and then to start, this is my shape, so we can rotate easily. So we're going to put starting point and the dot in the top of that side. And then we're going to rotate our shape to see how many times could fit in the exact same position. So if we slide them 90 degrees, that's one. Okay, and again, one that is right here, and we stopped in the same position, and then we do one more time, exactly. So that's exactly in the shape position, and then the dot is on the bottom, and then we slide one more time, and again, we can fit in the same position. and that is the third rotation, 90 degrees. And then if we do one more time, we will be back in the beginning. So we did 4 stops. So that tells us that there is a 4 rotational symmetry. 4 rotational symmetry of the square. We also can prove our diagonal, so the or our symmetry, line of symmetry. So we say that this was one of our symmetry. So if we take that and do the line through, okay, we can say if we fold the paper, it will match perfectly into making 2 congruent triangles, and they're right there. Okay, good. And then also, if we do opposite side and cut that in, we will see that is also matching into the half of 2 congruent triangles. That's a 2 line of symmetry. And then if we do the horizontal cut, it shows that there is matching also. There is horizontal a line of symmetry. And then if we do vertical line, that it will shows us that we can also have a half of a square identical. So line of symmetry, 4 line of symmetry as well. We can see how the to be rectangle, you need to have straight lines and right angle. So the square is rectangle by definition, and if fits there. Square is also rhombus, because to be rhombus, if I just rotate this and I can see the kind of rhombus. To be rhombus, you need 2 opposite angles need to be congruent. So that's the proof. Opposite this and this is opposite. They're congruent in a square. This angle and this angle are opposite and they're congruent. So also to be rhombus, you need to have a side same. So this is equal to this and this is equal to this. All sides are the same. So rhombus, a square is a rhombus, but not every rhombus is a square. So that's need to be kept in mind. Also, the sides could be extended, so we can explore this parallelity of the sides. So if I extend the lines, this BLT segment in this AD line segment, they are parallel. So we can say that we can find room right here. Then AD line segment is parallel to BC line segment. And then also this AB line segment is parallel to DC line segment. We can see if we extend the lines, we can see how they slide down. Used my ruler easily, that these points never meet. They will always be the same. Every point on this line segment is going to be always apart, same apart from this line segment. So BA or AB line segment is parallel to CD line segment. Okay. We also can explore perpendicularity of the, so we can see that if we extend the lines, this line BC is line segment is perpendicular to BA, or AB is perpendicular to AD line segment. So if we take this AD line segment is perpendicular to AB line segment. Okay, we can look all around. So AB is perpendicular to BC. And then BC, do this, BC is perpendicular to CD. And also CD, line segment, is perpendicular to AD, line segment. So we explore a perpendicularity of these line segments. So this will be all about square. I hope you enjoy, and I hope that you learn something from me, and see you next time.